Review set 8A, question 11. Suppose X is normally distributed with a mean 25, standard deviation 6, find K. Okay. I better write that down. X is normally, so the mean's 25, the standard deviation 6, distributed as normal. Right. Now in A, they say the probability of X something. I can't remember. But what I'm going to do is start drawing a little normal curve, like a bell. There we go. And okay, the probability that X is smaller than K is 0.7. Okay, so 50% is halfway, and that's 25. To get up to 0.7, I'm somewhere in here. As in, my K's somewhere about there on the curve, right? So this area is 0.7, smaller than or equal to K. We're going to find these values using the calculator. So you need to inverse norm this. You can probably just write your working like this. K equals inverse norm. And let's go to the calculator and figure it out. Alright, so we go to dist again. It is number 3. The area is 0.7. I'm always going to work from the left. The mean was 25. Standard deviation was 6. I don't know, what do we guess? Maybe 27, 28. Let's find out. 28, right. 0.7, 25, 6. So that can be the working out. And K was approximately 28.1, I believe. Just double check. Done. In B, I'll go back to the questions. The probability that X is greater than K is 0.4. Right, so as is my want. I like to have a little bell-shaped curve, at least mentally. Right, so the probability that we're greater than some K is 0.4. Once I've got this picture in my head, it helps me figure out what I need to do in the calculator. Inverse norm, 0.6. So if I'm always working from the left and there's 100% area under the curve, or probability of 1, then I'm going to put in a 0.6, 25. I know my answer should be, well, it should be bigger than 25 but smaller than 28. And let's find out what it is. We can probably just copy this, change the probability to 0.6, and we get 26.5. So note that I'm making little predictions. And in C, I might do it. I might do C up here. Let's just make some room. C's slightly harder. think. What did it say? The probability that x lies between 20 and k is 0.3. The probability that x lies between 20 and k is 0.3. So there's one standard deviation is 6. 20 is more than one standard deviation lower than 25. And one standard deviation gives us 34.1% of our area. So we'd have 34% if we got down to 19, but we're slightly higher than that, 20. I'm not sure. I'm not sure if k is slightly above the 25 or slightly below. So it's a little bit hard to draw a picture for this one. I'm going to guess, I don't know actually, 30%, 34% would be down to 19. I'm going to guess it's slightly below. I could be wrong, but there's a k in here and it's pretty close to 25, I'd say. All right. So I'm still, maybe my picture's not great, because I'm not quite sure what side of the 25 that'll be, but you know, I know that I know the answer should be somewhere around 25, and it's doing that prediction so that if I got an answer of 10 or something like that, I know it's gone wrong. Right. Now the way I'm going to work it out is to figure out what this probability is in here. Okay, so I'm actually going to first think, well, what's the probability that x is smaller than 20? We can find that using normal CDF, where our lower is minus 1 times 10 to the 99, our upper is 20. We'll need to enter in the mean and the standard deviation, and we'll get an area. Okay, so we're going to normal CDF. It's number 2. Lowers right, uppers 20. Mean 25. Standard deviation 6. And we get 0.202. Okay, which means my drawing was slightly out. Turns out k is actually just above the mean, because the mean's going to happen smack bang in the middle at 50%. I've just found out that this area here is 0.202 and we're just over 50%. Right? So we could use that area. We could say the probability that x is smaller than k has to be 0.202 plus 0.3 equals 0.502. Now, you could, if you like, have started the question this way with an equation. You could have said this statement. So some people like to jump to this right from the start, but I just do it in steps. From here, you know, I don't think there's too much difference to that. So we need to find k using inverse norm, and using this probability value that we've got now, which is just over 50%. So mean, standard deviation, and we're going to get a k which is pretty close to 25 but slightly bigger. So we're going to inverse norm. Our good friend Norm is back again. 25, 6. I'm always working from the left in these questions in case you've got an older calculator. And we get 25.03, it's pretty close to 25. So if it was 3 sig figs, I could just leave it as 25, but I'll write 25.03. Okay.